Welcome to Study Loop.
Okay, this is question 2840, and we have a few different wires and different paths, or different circles specifically, or loops, are shown labeled A, B, C, and D, and we want to figure out what the line integral is, or integral of b.dl for each path. So here we need to use Ampere's law, where the integral of b.dl is equal to mu naught times the current that's enclosed in that path. So let's start with loop A. So loop A here, we see that the current enclosed is 0. So I enclosed here is going to be 0, which means that the line integral E dot dl is also going to equal 0. So that's an easy one. For part B, let's take a look at the currents enclosed. And now for loop B, we see that it's enclosed by current I1, but I1 here is pointing into the page. So we need to know which sign the current really should be. So if we, let's see, we're told here that the line integral is going around the path in the counterclockwise direction. So using the right-hand rule, when we're going around the path in a counterclockwise direction, currents out of the page are positive and currents into the page are negative. So here we have this current is going, I1 is going into the page, so that's going to be negative here. So our I enclosed is going to be negative 4.0 amps. So we want our b.dl in this case to just be equal to mu naught times our minus 4.0 amps. And that's going to give us minus 5.03 times 10 to the minus 6 Tesla meters. I'm going to set this unit here as Tesla times meters, because we have a magnetic field in Tesla and then another length, which is measured in meters. Now for loop C, let's take a look. We have two currents enclosed here now. So we have I1 and I2. So remember, I1 we are going to take as negative because it's pointing out of the page, or I'm sorry, into the page. So I1 here is negative, and then we need to add to that I2, which is coming out of the page at us. So that will be positive. So when we add this up here, we're going to get minus 4.0 amps plus 6 amps. And when we add that, that gives us 2. And so now our line integral here is going to be equal to mu naught times 2, which will just be 2.51 times 10 to the minus 6 Tesla meters. Finally, let's take a look at D. Path D now encloses all 3 of these wires. So we have I enclosed is going to be I1, and remember I1 is pointing into the page, so it's negative. So we have negative I1 plus I2, and now I3 is also pointing in the same direction as I2, so it will be positive as well. So when we add that up, I enclosed will be minus 4.0 plus 6.0 plus 2.0. So that will give us 4.0. And so now when we take the line integral, we're just going to multiply mu naught times now positive 4.0. So that's going to give us the same thing as part B, except now it's positive 5.03 times 10 to the minus 6 Tesla per meter.